Welcome back to the MLSecOps podcast brought to you by Protect AI. I'm Maddie, your host for this episode, the community manager for Vulnhuntr, which is the world's first AI ML bug bounty platform powered by Protect AI. And today is going to be an interesting episode because I'm actually with my two favorite coworkers here at Protect AI, Dan McInerney and Marcello Salvati. So do you guys want to just tell our audience what you do here at Protect AI?
What do we do here?
Please. First.
Okay, so I'm Marcello. I'm a threat researcher here at Protect AI. So that involves triaging reports, understanding the vulnerabilities, also automating a lot of the back-end stuff with the bug bounty platform that we run here called Vulnhuntr. And this is Dan McInerney. Dan?
I do exactly the same thing. We're in the same role. So there's not much need for double introductions, but yeah, we just kind of handle the cutting edge research in the AI sphere, both with AI and security of AI.
Yeah.
Awesome. So I'm just going to dive right in and open up the conversation to Vulnhuntr, which is the Python static code analyzer that leverages LLMs like Claude to essentially find and explain vulnerabilities, which you two actually created along with Ethan, who's another threat researcher in Protect AI. So can you kind of explain what inspired you to start it? Was there a problem that you saw and a need?
Yeah, so this actually started right when ChatGPT dropped. He was actually the one that told me about ChatGPT. He texted a group chat that we have and was like, hey, you guys seen this thing? And I check it out. I've been working at Protect AI for 6 months or something. I don't know. Don't quote me on that. But I check it out and it was like, whoa, this thing is insane. Because just literally the day before, we didn't have a chatbot like this.
No.
And so as soon as I saw it, obviously being hackers, the first thought is,
was like, can we use this to find vulnerabilities?
can we destroy things with this?
Yeah.
Very natural, very natural.
Yeah, exactly. So we I think everybody in the security community just randomly started copy pasting code into it to see if it can find some interesting vulnerabilities. And at the time of GPT-2, GPT-2 was the first release, public release. I forget. Well,
Yeah,
in any
so.
case, yeah, GPT-2 or something. It wasn't that good at it per se. ChatGPT is actually still not kind of good at it, honestly, to be perfectly honest. Claude is a lot better. But basically the further along the GPT's releases came out, the better it kept getting. And currently it's at a point where we were able to actually build a tool that actually is able to find vulnerabilities just using LLMs.
Right. And so there was a lot of reasons why Vulnhuntr wasn't released earlier by anybody else.
Yeah.
It was actually Claude 3.5 that was the release that made it really possible to do autonomous discovery of vulnerabilities. Because the title we're claiming with Vulnhuntr is that it's the world's first autonomously found AI-powered 0 days.
Yeah.
Meaning you just give it a project, you just dump the project, point the tool at that code, and it goes and will just tell you if there's any 0 days. You don't have to just copy and paste snippets. You don't have to say, hey, this code looks suspicious. Let's drop that in. The reason for that was context windows. So ChatGPT 3.5 came out, and it was only a context window of 1,024 tokens, if I'm not mistaken.
Yeah, that sounds all right.
Which is just not enough space to fit a complex vulnerability chain.
So you had to do complicated things with RAG systems and a bunch of other stuff to actually get the thing to work, which it makes it a lot more complicated, and also the results are dramatically less good.
Less good. Yep.
Less good.
Yep. Definitely less good.
Yes. Good. Dramatically less good than if you were just to paste the actual vulnerable snippet directly into the context window. So
yeah,
that's.
And so what's interesting is right after Vulnhuntr dropped, Google dropped a Project 0 day where they found a memory corruption bug in SQLite.
Oh yes.
Which they then said was the first AI found memory corruption bug in popular software.
Yeah, in the wild, quote unquote. Yeah.
Which, Vulnhuntr found 14 in the wild in the previous 3 or 4 months.
But just to make the distinction though, Vulnhuntr doesn't find memory corruption bugs.
Right.
It only finds web application, your standard OWASP top 10 kind of stuff.
So what we're seeing right now is I think we're going to see a big explosion of these tools that can automatically find vulnerabilities using LLMs. And right now, obviously, all of them are kind of specific. specific to something. Like ours is specific to Python. Google's was specific to memory corruption bugs. I think in the very near future, there's going to be a big tool. I suspect maybe by GitHub, probably is in the best position to do it.
For sure.
To have a generalized tool that you can just feed a project and the LLM goes through and finds vulnerabilities.
Yeah.
The reason that we did this to begin with is because LLMs are really, really good at taking input and then reasoning about it and then giving you some kind of structured output. So before Vulnhuntr, there was static code analyzers, obviously. There's things like Sneak. There's things like
SemGrep,
Veracode, yeah. The problem is they just kind of read like lines of code at a time. They don't have the context of the whole project.
Yeah, I mean, and mostly it's just regex too at the end of the day. It's like literally just like trying to find specific code patterns that are hard-coded into the actual software. And there's no reasoning behind it. Like,
right.
Unless you're running it in a sandbox, which sometimes these products have, but they're generally not that good. So like this is the first time where, like you said, like they can reason about, like, it's not just like the code. It's like, hey, where does the input come from? And like the LLM can make these determinations by giving it more and more of the project's code, which is what Vulnhuntr does basically. It was an entire process of actually getting that down. I don't know how far we want to go down the road with that.
I'm happy to go into the technical details later, but
it was
supposed to be the intro, and now we've
months
like 6 minutes in.
Yeah, months of
No, this is great. Were there any like aha moments that you had when you were developing it where it kind of just clicked and you were like, oh my God, this is a game changer?
Yeah, definitely.
Yeah. I think the first time I found the vulnerability, that to us was just like, whoa, okay.
That was pretty cool.
This actually works. First off, like that was the big thing. And then once Ethan started running it on a bunch of stuff, like he started finding like 12 of them like back to back in like a span of like a few hours, I think, right?
Yep.
Or at least like a day or two. Like it was very, very fast.
Yeah, he just started pointing at things and 0 days started falling out.
Yeah.
There was some other stuff that we did that like kind of let us know that it was even technically feasible. One of which was, it's actually, I said this earlier, it was the fact that Claude 3.5 came out, and then I put a bunch of code into Claude 3.5, and it was actually really, really good at analyzing the code. And that was when I was like, okay, wait, I can make a weekend project of this. Let's see if this can actually find vulnerabilities. And that weekend project, I pointed it at a project. I just whipped it together on something really simple, and it found an O-Day in a GitHub project with like 200 stars. So I'm not going to go report that to Meter. We're not going to get a CVE for a 200-star project.
Yeah.
But it like was an aha moment that this was
working
possible.
Yeah. And then I found something in like a 10,000 star repository.
Yep. And that was like, okay, well, now now
we're talking.
This might be now a long project.
Now we're cooking, now we're going. And so I just kept going from there. And I think like the biggest, what is it? The biggest, it was like 60,000 stars was like
65,000?
65,000 stars, right? Like the biggest project that I found a vulnerability in. So yeah, it's definitely produced some results. And we actually have code to back this up, as opposed to everybody else's approach up until this point, where the whole other rabbit hole.
We should talk about this.
Yeah. Where the academic papers tend to, because this is not a new idea. Like this has been, been researched and active area research since ChatGPT came out. Like the LLM started, hit the scene. But the problem is like all of the research so far was in academic papers, who like mostly gave long-winded explanations of like architectures of how would I build this if I were to actually build it, and they never released any code or proof of concept or anything along those lines. And a lot of it was sort of like misleading as well. A lot of the way they titled the papers and stuff like that. So it really bothered us. And Dan specifically, like it really bothered him. And because of that, like we were adamant that not only are we going to build this thing, but we're actually going to release it to make sure that, hey, this is actual code that you can run and actually like.
Right. And to be fair, so when I was reading all the academic papers, to be fair, I don't necessarily think the titles were misleading, but they are attention grabbing. If you know what I mean.
Yeah. It's like clickbaity.
In what sense? Is there an example of one that you might remember off the top of your head?
Yeah, there was one about AI agents. So technically, the titles that were most misleading were actually the news articles about the academic paper.
Yeah.
Okay.
So the journalists would kind of extrapolate. And I remember one of the titles from the journalists was AI can find and exploit zero-day vulnerabilities. And so when we released Vulnhuntr, that actually got brought up a lot by people saying, oh, this wasn't the first time that AI has found autonomous 0 days. Because look at this news article. But that news article was referencing a paper that just found that AI could find one-day vulnerabilities.
Yeah.
Like that it wasn't trained on. So they gave AI a whole bunch of vulnerable code that they knew was vulnerable, and everyone knows was vulnerable because it had a CVE, and told the AI to find vulnerabilities in it. And the AI found it. And the AI was not trained on that code, meaning that's brand new information to the AI, and it proves that AI can technically find 0 days, but it didn't actually get any CVEs or find 0 days.
Yeah.
So, to be fair to the academic authors, that's not necessarily their fault that the news articles were headlining
We're
it.
very clickbaity.
We're clickbaity.
Yeah, they were
Yeah.
definitely clickbaity. Yeah, that's part of the problem.
So would you say that Vulnhuntr also teaches developers in the process? It's kind of like like a two-way conversation, or it benefits both sides?
Yeah, for sure.
Mm-hmm. Yeah. And from a like defensive standpoint, yeah, absolutely. I mean, I would say actually that this is a great tool for blue teamers to actually just run on their code bases because like if Vulnhuntr can find it, I mean it's not like Vulnhuntr is good, but it's not finding like super complex stuff. It does find like multi-step exploits, but it's the complexity level. I'd say it's that the vulnerabilities that it finds is from like low to medium. I'd say, right? Like
Yeah, I would say like an average decent bug hunter or pen tester would find mostly the same vulnerabilities given X amount of time.
Yeah, exactly.
Okay.
So
It just speeds up the process.
Yeah,
it makes it more efficient.
You hit enter, and it's just
Right.
and it's just done.
here's all my bugs.
Yeah, so it's a good tool for blue teamers to actually run because it's like a good first pass like at things, right? Without too much effort because you just point and click it, and like if Vulnhuntr finds it, like odds are that you would have like the pen tester on your next like pen testing round would have found that. Like it's a good.
Got you. Okay.
And so it also has an analysis paragraph where it tells you logically step by step why it thinks there might be a vulnerability. But the real value too is if you write really clean code, you might not know what the hotspots of your code are and what like is the most important security sections of your code. And so Vulnhuntr may not find a vulnerability, but it will tell you, hey, I mapped out this chain of user input, and right here seems to be like there might be some potential issues. You should go investigate, but it's a great way of highlighting the hotspots of your code for developers, just to make sure that you go back to that one little section of your code and say, you know what, okay, I did this right. That's all sanitized and all that kind of stuff.
So going back to how Vulnhuntr has found 0 days, can you give us an example of some of the 0 days that it's found and exactly why it was so impactful or significant that really made Vulnhuntr such a powerful tool?
I think the most what would be one of the like most complicated vulnerability that I think like it was able to re-find, if I recall correctly, one of the vulnerabilities in MLflow that was like a multi-step exploit, and that to us was kind of really another moment where we're like, oh damn, like this is actually like that's impressive. Like at that point, like that's actually
that was the original MLflow LFI that I found. That was the first. I think it was my first CVE ever, actually.
That
was 2 years ago.
But in terms of new ones, I don't recall. I'd have to think. I think like there was if I recall, there was like it's usually like I think I wouldn't. I mean, there's a lot of IDORs. Like there's definitely like I found a lot of IDORs.
The RCEs were pretty cool.
Oh yeah, I did find RCE.
I found multiple RCEs, and RCE is like the gold standard for a hacker.
Yeah, that's true.
Take over the entire system when you have an RCE.
Yeah, it was actually very interesting because it was in like a request that seemed very innocuous. So the fact that it found it was like very impressive. I think. Like,
one that I remember was the Ragflow one. Where
that was the RCE one, right? Yeah.
Ragflow was like calling a class. It was using a dictionary, and the dictionary
was dynamically
calling
a class.
Functions.
Yeah,
classes.
Yeah, or functions. Yeah.
Which is, it's kind of complicated to read, and so if you were just reading over the code, you might just skip right
over it. Yeah. It's like easy.
Vulnhuntr's eyes were like, nope, this is definitely an RCE. And credit to the Ragflow team, I hit them up on Discord, and they're like, okay, fixing right now. And within like literally minutes
they fixed it.
He had fixed it. It was awesome.
Yeah,
nice.
Yeah,
that's great.
So would you say that these are pretty widespread or common in AI ML systems across the board, RCEs and these kinds of vulnerabilities that you've been finding?
Right now, yes. Like because we're in a weird transition period. Well, not in a transition period, but it's mostly just like the beginnings of like an entire ecosystem of tooling. So it's like, like the way I like comparing it is like the 1990s with like everybody trying to figure out like just networking and like all the server side vulnerabilities where you could just like, I don't know, like just pop into somebody's FTP server randomly because like security was never a concern. So we're sort of in that phase now where people are just like creating stuff without thinking of the security implications. I think like that we're gonna get to a point where like we're gonna start seeing a lot more security conscientiousness.
I think so.
Oh wow, I did good. And in like the next 2-3 years, probably I would say probably 2-3. I feel like that's maybe a little bit more than that.
I agree.
But like for now, it's that's sort of like the state of things.
And it's interesting that all the 0 days that Vulnhuntr has found have been in AI tooling. And that's not on purpose. That was just because we went to Python most starred projects and hit, sort by popularity.
Yeah.
And they're all AI tools. Like everything on GitHub right now that's really popular is an AI tool. And it's pretty much all written in Python, which is great for us. But I think that does also highlight the fact that the ecosphere of AI tooling in the open source world is broadening very quickly, and it's often being done by machine learning developers rather than
Security professionals,
web app engineers.
Yeah.
But I think you can make a very similar metaphor back to mobile apps when they first came out.
Yeah.
Mobile apps when they first came out were ridiculous. Like the Pizza Hut app, you could literally just cancel one request or a response that was coming to the request and get free pizzas. Like it was literally security from 1993.
Yeah. Yeah, it's a sort of a general trend in like anything new technology.
Absolutely.
Like security is sort of like always trails a little bit behind for like the first 2-3 years.
Yeah, but then it picks up. So,
and then it picks up, yeah. And they just rediscover all the previous mistakes, basically.
And this is why we have Vulnhuntr to begin with, is to speed this process along. This is why we have Hunter. This is why we have all our bug bounty programs.
Yeah.
We're trying to make that gap between 1999 security and modern security as short as humanly possible.
Yeah.
And I think that we've, done a pretty good job at that, considering we have 300 0 days we found on the Hunter platform.
Yeah.
Again, don't quote me on that. I'm not actually sure what the number is.
Yeah,
I think it's about 300.
I don't know. We'll leave it at
300. Okay.
It's 600.
Yeah. Just keep the number up.
1 billion.
Yeah.
No, 100%.
So if we were to take a step back and think about Vulnhuntr in the context of MLSecOps, right? Where does that kind of fit in, and how does it kind of align with the MLSecOps framework?
It's part of like your security process. Like when you're evaluating, like say you're using like dependencies for a specific like machine learning project or some internal AI tool or something. Like you could technically use Vulnhuntr to like scan dependencies to see if there's any low hanging fruit in like any of the dependencies that your project relies on, I guess. That's one use case for it.
I would see it as very, very useful into your CI/CD pipeline.
Yeah.
So when your developers are creating Python tools, they automatically get scanned. So DevSecOps, a lot of them are using tools like SemGrep and Sneak and Veracode and all these static code analyzers as a first pass to find vulnerabilities. They really should be using LLMs as a first pass as well, because it's not expensive. I mean, Vulnhuntr takes tokens, but it only costs less than
a couple
cents.
Yeah,
it's pennies to.
The max is probably like a couple of dollars, which is nothing. It's definitely that's a good point. Like you can use a combination of like both legacy sort of like static code analysis and also Vulnhuntr to scan all of like you have a pipeline and just put that right into that pipeline.
Yeah, I think we're in this like interesting stage where the transition between traditional machine learning and LLMs is not complete. I think eventually LLMs will take over 90% of like the AI world.
Yeah.
But it's actually still quite useful to use traditional machine learning in things like log analysis, and then give the output of the traditional machine learning saying, hey, here's a bunch of logs that we think might be vulnerable, and then giving that to the LLM to then further refine and give you some logic about whether that log file or that log entry is vulnerable. But all of this is to say you can just inject all these tools right into your developer pipeline. Yeah. That way these 0 days never come and see the light of day. That's the whole point of MLSecOps. You want to make sure the security is done before you release the product.
Yeah. Right.
And this speeds that process along.
You don't want to be reactive, you want to be proactive.
Exactly.
Yeah.
So that's the big thing.
So what kind of teams would benefit mostly from from something like Vulnhuntr? If it were to be integrated or used in certain workflows or within that ecosystem?
Honestly, probably Python app developers.
Yeah.
If you're building out Python apps that stand up a web server, like Fast API,
Yeah, if it's network connected.
if it's network connected,
or something, yeah.
they're going to benefit the most from running Vulnhuntr on all of their code whenever they make a commit. Because it's not like it's an expensive or time consuming. It's just a really easy way of seeing if you made any semi-complex mistakes.
Mm-hmm. Yeah, I agree.
But then also pen testers. I mean, obviously.
Yeah, I mean, a lot of like,
Right.
especially if you have internal pen testing teams, like
Yeah.
they'll benefit from this tremendously. Like it's definitely like a dual use tool. Like both sides can definitely benefit from it.
Yeah.
But to be clear, for the pen testers, you do require the source code of this.
That's true. Yeah, it's more like a white box thing. Right?
Yeah.
Where you have
so you're not going to be able to
access
point
source code.
Vulnhuntr at web
like
app.
So yeah, this isn't like a I guess now they're called hack bots, right? I guess
Right.
like this isn't like a black box tool that you can just point at like just a random server. Like you need access to a source code.
Right. So I guess the defensive side would actually benefit more and get more utility out of this than the offensive side.
Yeah, for sure.
So do you think with tools like this that come out that more teams would kind of adopt more robust MLSecOps security practices overall? This would kind of shift the way that they're trained across the board?
Yeah, I think it would change the process for sure.
Yeah.
I mean, it's just an evolution of the process that was already there. So like MLSecOps is coming off of DevSecOps.
Yeah.
There's some small changes and some major changes between DevSecOps and MLSecOps. But the fundamentals of DevSecOps is going to be find the vulnerabilities before you release the code and before you do that kind of thing. And so Vulnhuntr fits right perfectly into that baseline ability. Like the differences between DevSecOps and MLSecOps is more or less just...
I mean, it's more of just like a mental, it's more like an adjustment. Like it's more of like instead of just like development, like as a whole, you're mostly focused on like machine learning stuff.
Right. So you have some things like
Specialized,
artifacts.
I guess. Yeah.
Model
exactly.
files don't exist in traditional DevSecOps.
Yeah, exactly. Yeah.
So there's like small minor differences, but the core process is still the same. You want to remove the vulnerabilities before they hit production, and Vulnhuntr fits like a puzzle piece into that little niche.
Yeah. It's all part of the onion. They're all part of the security
part of
onion.
the onion.
Yeah. It's all part of the
All
onion.
part of
It's
the
layers. It's all
Yeah.
layers. Shrek, you got to really take the Shrek approach to security. Just generally.
I mean, I think that's a great quote for this episode.
Yeah. There you go. You're welcome.
So I want to transition into something equally as exciting, and it's part of Hunter, which is model format vulnerabilities.
Yeah.
So just to give people context or background, and I'm going to do a very high level overview of it, but typically on Hunter, we've done OSS vulnerabilities, and now we're kind of shifting the focus into focusing on model format, model file vulnerabilities that, first off, are also double the amount of our typical bounties that we have,
I mean,
which is
at least,
awesome.
I mean, a minimum double.
But also it's relatively new, right? I mean, it's not something that I think maybe everyday hackers might know how to find. I mean, what do you guys think? And if for listeners that might not know and that are very beginner friendly, how would you just go into those vulnerabilities? How would you explain it? And why are they important?
So baseline first is when you think of MLSecOps, I mean, there's really three categories of security in MLSecOps. And this is why MLSecOps is slightly different than DevSecOps. You've got the supply chain, which was Hunter. That was all the software that goes into building and storing and training models.
Yeah, the models themselves, yeah.
And then you have the model file, which is the model itself. The security of the model file is interesting because a lot of people don't realize the model file can execute code in many, many instances. A lot of times it's just a serialized object that you can just inject your own code into, and the model still works. It still makes predictions and does stuff, but then it also calls back to a
compromises your
and then the last part is LLM security, which is like, a firewall for your LLM, making sure that it's not jailbreakable and stuff like that. So Hunter already takes over that first supply chain section. All the tools they use to build, train, and store models. And now we're moving into that middle section, which is the model file itself. It's a really interesting field because traditionally, machine learning engineers have stored their models in pickle format. And pickle is well known to have a deserialization problem.
Yes.
When you load the model,
It's not a secure file format. Yeah, that's yeah. So when you load the model, like there's like if it's malicious or like if it's compromised in some way, an attacker can like inject basically a malicious payload in the model file so that when you load it, it executes code on your machine that can do basically anything. So there's been some like pivot, I guess, for lack of a better word, to like safer model file formats, but those two come with their own issues sometimes. Like we've had a bunch of reports, for example, even previously to Hunter making this transition on like memory corruption bugs affecting some of these libraries that load these safer model file formats.
Right.
So they come with their own set of challenges and security issues as well. So it's not like it just because it's considered safe doesn't necessarily mean like it's completely devoid of attack surface.
Right.
Yeah.
And so like there's many different kinds of model formats. Pickle was the one that was used for the last 10 years.
Yeah.
Because it's convenient. It's just Pickle essentially just takes a Python object from memory and stores it to disk.
And it's
then
built
puts
into
it back
Python, so you don't have to download anything else.
Super easy.
Yeah, super easy.
But now there's a whole bunch of different ones like GGUF and
Right.
No.
Yeah.
PD params and JSON, like just a million different kinds of file formats to store these. And what we're finding is that there are some issues in everything from zip slip, where if like a library allows you to upload a tar file, then sometimes that leads to a zip slip vulnerability where you can now overwrite files as soon as you load a model. There's issues with memory corruption, like out of bounds, all kinds of things. But if you want to get started in this, I would say go back and look at the original Pickle deserialization issues.
Yeah.
That there's a lot of resources online to look at how that works. Get a good feeling for that. Then go check out the Hunter model file vulnerabilities page to see what kind of other formats that we support for these bug bounties. And then go Google what other kinds of attacks you can do to those. So I would start with Pickle, and then I'd probably move into Keras. Keras is another model file format that has had remote code execution issues. It's a little more complex. It's actually a lot more complex than the Pickle one. So start with Pickle, go check out Keras, and then start doing some research on the other model files from there. You'll have a pretty good idea of what we're looking for and what would actually impact the security of AI as a whole.
Also, if you're familiar with like already like you're a reverse engineer and you're familiar with like file format corruption vulnerabilities, like that's it generally like that applies here as well. So I mean, it's at the end of the day, it is a file. So I mean, like it like if you're familiar with those kind of classes of vulnerabilities, like you'll feel at home immediately. Like it's a little bit like the file itself is structured always a little bit differently, but in itself, like it's the same deal.
Yeah, we're paying more for these because they're harder to find.
Yeah.
Right.
Yeah.
They're much harder to find. It's a little more gray area about like what exactly is a file format vulnerability. But
And this just builds off of typical web hacking skills that you would traditionally have. Is there any other special things that you might need to learn or know to find these?
Well, I mean, it's not necessarily like web hacking in this particular case. Like the skill set is somewhat different, I would say.
I would agree.
But it's like if you're familiar enough, like if you're like already like a hunter, for example, and like you're familiar with web hacking, like the transition between like web hacking and like this kind of stuff, it's not that difficult. So I mean, you can transition pretty easily.
Definitely different though. I mean,
It is definitely different. Yeah.
You're not finding local file includes or cross-site scripting in model files.
Yeah,
Model files, you're looking for strange things that happen when you load a file in a library.
It's like basically strange things, like what happens if you like flip a bit in this part of the file.
Yeah, what if you change a parameter that's stored in this?
exactly.
What if you compress the model file
Differently
before, like what if you payload the model file with an injection, like a Pickle attack, and then compress it? Like, does that bypass scanners like model scan?
Yeah.
So if you ever have a question about whether something's a vulnerability, it's a good idea to start with our open source tool called Model Scan and see if you can payload a model to execute code and have Model Scan not detect it. If you can do that, then you are definitely on the right road. You probably have something valuable to submit.
Yeah, agreed.
So would you say there's a lot of ways for exploitation with these types of vulnerabilities? And also, are they becoming more common? At least that you've seen in your field, it's not as niche as it may seem?
Yeah, like it's actually insane to me when this all started. I thought it was really just Pickle deserialization bugs. Like I thought that was it, And as soon as we move into a safe file format, like Keras or just a different file format than Pickle, everything would be solved. That has not been the case, which is it's interesting. The weird part is we have safe model file formats that have not had any bugs. Safe tensors, I think, is one of them that I don't think we've ever seen a vulnerability in those. So why everyone doesn't just start moving into those safe
tensors? Yeah, I think
I'm not sure why.
It's probably like just tech debt. It's a lot of it is probably. So. I'd assume like a lot of it is tech debt. sometimes maybe there's like something about that file format that maybe doesn't work with like other systems that they already have set up. Like
Yeah.
there's probably a lot of stuff. But yeah, although like I don't know if they just be. I'm assuming you can still have memory corruption bugs with safe tensor files.
Yeah,
though,
it's
right?
it's certainly not foolproof.
Yeah, exactly.
But
it's
as
a
of
lot.
today, we haven't seen any issues.
Yeah, okay.
Which means it's probably a lot safer than some of the other formats like Keras, which
Yeah.
seen many issues of
Yeah,
code
makes
injection.
sense. Makes sense. Yeah.
But the issues that we're seeing now are very interesting. We're getting beyond pickle, and now we're starting to see things like brand new attacks by injecting code that's formatted in a very specific way, so that now when you load the model from Hugging Face, it's not just a pickle deserialization. It's like code is being executed based on, let's say, a file that is included in the model file folder. So some libraries are loading like config.json when you download from Hugging Face. So the model is fine, it's totally safe, but the config.json actually points to something malicious somewhere else, and the library automatically executes that. That is right on the gray area of whether that's a model file format vulnerability or not, because it's not in the model itself, but it's an example of how this attack chain as base is, I want to go download a model. Is it safe to download this and open it?
Yeah.
That is the amount of vulnerabilities we're seeing in that chain is expanding much beyond what we saw before, where it was just pickle deserializations.
So it's pretty new then, right? I mean, this is all we're kind of learning in real time.
This is absolutely brand new. This is the cutting edge, I think, of AI security right now.
For sure.
So if we were to zoom out and look at the bigger picture, right, in terms of model format vulnerabilities, can you give almost like a real attack scenario? I know that there was a model serialization attack or vulnerability. I don't know if you guys heard about it or you've talked about it in other content, but can you just kind of walk through, I guess, that attack process and its potential impact?
Yeah, I mean, I think the most straightforward impact is that like you can potentially take an existing pickle model on Hugging Face, for example, and inject it with some malicious code, and then did what, like, I think, Dan, you did this actually, where you could just send the link to the pickle file via email to like a bunch of engineers, and like in a phishing email, and whoever runs it, you'll basically be able to compromise their computer. I mean, that's one aspect of it, because it's sort of like I mean, it's not, I don't think a lot of machine learning and AI engineers are security aware sometimes. So when they see pickle files, they're not necessarily thinking, oh, this could be used maliciously.
Sure.
So that's part of it. And I think there's also the fact that a lot of like traditional antivirus scanners don't really scan these files, or at least they're not good at detecting payloaded like malicious pickle files. I'm assuming that they're gonna catch up to that at a certain point. But as of like when last time we tried, like they weren't really good at it.
Yeah, it was just a few months ago. I don't know, 6 months ago or something. We released that blog post showing that none of the antivirus scanners detected a very basic base64 encoded Python payload in a model file.
Yep.
And models are viruses. I mean, they can execute code.
Yep.
So a phishing email, I feel like this is the golden age for phishing AI departments, because machine learning engineers have massive amounts of permissions, usually, in their networks, because they have to. They have to be able to reach data from all over the place, put it all together, and then have to have access to massive amounts of computing to train models and things. So, and they usually come from academic backgrounds, not professional developer backgrounds.
Yeah.
And again, these are generalizations. This is just what I've seen. I could be completely wrong, but it's what I've seen when I've gone and talked to many of the machine learning engineers around the country. Now, you send them a phishing email with a pickle file, and you say, hey, I was getting an error with this model. Can you just load this and tell me what why is the learning curve all screwy like this? They're just not going to think of this as suspiciously as a Word document that has macros enabled.
Yeah.
Like, that's suspicious. When you say, oh, hey, can you just enable macros on this Word document so that I can execute code? But no, a model file, they may not even be thinking it can execute code.
Yeah.
It's golden age for phishing machine learning engineers.
And also this on the supply chain side of things, because like, in a traditional ML or AI stack, sometimes you have like, I don't know, one part of the code that's doing OCR on something that needs a specific model from Hugging Face. Like, what happens if like all of a sudden that model gets compromised, right? So from the supply chain side of things, this is also an important aspect of it, because it like you have a lot of like in a well engineered like service of some kind that uses machine learning, you're going to have different components of that service using different kind of models. So from the supply chain side of things, like you're not always thinking, oh damn, like this thing is actually using this basically an executable to perform this task.
And I'm downloading from the internet.
Yeah, downloading from the internet. Yeah, so you really should basically think that these models are basically like exe files on Windows. Like they're basically the same thing.
Yeah, so there's a lot of real world risk. I mean, really,
Very, very significant real world risk. And I'm not trying to be hyperbolic. This is like from a hacker's perspective of 15 years, I would have loved to be doing red teams against companies with AI departments because I could fish them with model files.
Yeah, 100%.
Wow. That's it's really crazy when you think about that and all the possibilities and just how it's not that it's not being talked enough, but it's still, again, we've said it's very new. It's kind of, we're learning in real time how all this is unfolding and how it works.
As we watch these model file format vulnerabilities come in through Hunter, my mind is being blown because I really didn't think there was going to be a lot of creativity.
Yeah.
But it's like, you guys are defining the rules of the model file format vulnerabilities as you submit your reports, because a lot of this is just stuff I never would have thought about.
Yeah, that's true.
Like the whole config.json actually pointing to a malicious thing. It's not even the model file itself in that case, but it's
just the way the library loads the model, basically.
And yet it completes that attack chain of
we're still basically like the vulnerabilities that we already got are informing the guidelines that we're going to be putting on the website. So I mean that in itself is it's a lot. That's a lot of work too. Like, it's going to be interesting to root out all the gray areas when it comes to that.
Yeah, I'm sure. So tying this back into Protect AI, how does MFVs tie into Protect AI's overall mission? If you were to put a nice little bow on it.
Well, we've got those 3 sections of AI security: supply chain, model file, LLMs.
Yep.
This is squarely giving us the ability to discover 0 days before they're exploited in the model file format section.
Yep.
And nobody else has this capability, and nobody else is really doing this.
Yep. 100%.
Wow. Very interesting, you guys. Well, thank you. To all those hackers out there that are really interested in MFVs and want to take home $3,000 per vulnerability that you find, I implore you to please go on hunter.com. We'll be coming out with more educational content to kind of guide you through the journey and finding more of these vulnerabilities. Once again, I'm your host, Maddie. Thank you to our listeners for your continued support of the MLSecOps community and our mission to have security AI content. And a huge thank you for Dan and Marcello for joining us today. This episode was awesome. Be sure to check out within the description of this episode all of the resources that we kind of spoke about in this episode, as well as Dan and Marcello's contact information. If you want to hang out with them, you guys are available.
Sure. Yeah.
Hey, just show up at our house.
Right, yeah.
Text me, honestly.
We're all available.
I just put my number there,
Yeah.
Give you my digits.
Of course. Slide into your DMs.
Yeah. Slide into we love unsolicited DMs. Yeah, we love that. Yes.
I actually do love that. To be honest, I really actually do love when people just reach out randomly to me.
Yeah.
You may not, but I do.
I mean, I don't mind, depending,
Awesome. Well, again, thanks everyone for tuning in, and we'll see you next time.